All right, so we're gonna do notes I am a function, and today is strictly a review day. So my hope is as I say something, nothing sounds brand new. 100% review. Got it? So notes, am I a function? So we're gonna review this until all understanding of what a function is and how we got to this point in our math career. So many everyday phenomena involve two quantities, right? And how they're related, that's called a relation. So for example, you're related to your mom because she's your mom, and your relation is mother-daughter, mother-son. So we call that a relation. So in this blank, we're going to write relation. Okay? So in math terms, a relation is a correspondence between two sets. So two sets of data. Okay, to be more specific about a relation, we're going to talk about a specific type of relation, a function. And a function is, in our terms, is when each element in set A corresponds to exactly one element in set B. So here's my set A, and here's my set B. So each element in set A goes to one element in set B. Yes? So that is a function. Sounds like we got that, right? Not new. Perfect. And the next blank, we're going to write all functions. So that blank is all. A-L-L. All functions are relations, but only some relations are functions. Not every relation is going to be a function. So the two ways that you guys learned to verify them, one was to check to see if your x values repeat, right? So when we say x values, that means we're dealing with an ordered pair. So we have x comma y. And we want to just verify if our x values repeat. So if we're focused on just x values, we're going to look at 4, -4, 2, and 10. Are they repeating? No. No, they are not repeating, so that means that this is a function. So we're going to say, yes, it's a function. Okay, and then our second way that we learn how to identify a function is the vertical line test, or short, VLT, right? So VLT is if I take a vertical line and I trace along a graph, do I hit only one point at a time, or do I hit more than one point at a time? If I only hit one point at a time, then it is a, if I hit more than one point, it is not a function. So let's practice VLT. On your paper, you should have, it should have hopefully drew the line in for you, right? So imagine if you were to, pretend how that's the straightest line you've ever seen, okay? Imagine you were to take your line and move it along. Does it hit only one point at a time consistently? Yeah, it does, right? So because it does, we would say it passes VLT. So this pass VLT, and if it passes VLT, then it is a function. So we would say, yay, yes, you're a function. Because it passes VLT. Okay, same thing here. Imagine on your paper if your line could move. If I took this line and I traced it along, what happened?
You're going to hit at 2 points.
It hits at 2 points at a time, right? And if it's hitting it at 2 points at a time, what does that mean? It is not a function because it fails VLT. So then it's a no. Y'all remember that? I saw a head no. Yes, we do. We remember that. Can't leave out for 2 not remembering that. Okay? Before, I just want to know, if I pass vertical line test and horizontal line test, does anyone remember what that special function is called? If I pass the vertical line test and the horizontal line test. Nobody? It's called a one-to-one function. If I pass VLT and HLT, I'm a one-to-one function. That means there is a unique value for each x that corresponds to y, and vice versa. So not only do your x's not repeat, but your y's do not repeat. And that's a one-to-one function. So if we look at this one, this is a one-to-one function because if I had a vertical line and I trace my vertical line, I only hit how many points at a time? One. So it passes the VLT and it passes the HLT, so it is a one-to-one function. We'll dive deeper into that when we talk about inverses. But wanted to see if you want to recall. All right. So next thing we're going to review is domain and range. Domain and range. I like to think of domain and range as two old dogs sitting on a country porch watching the sunset. Their names are Dixie and Royd. Dixie's the girl, Royd's the old dog. And they're just sitting together watching the sunset. Dixie stands for domain, input, x value, and independent. All of these terms are synonyms for domain. Depending on your scenario, your situation, or your problem, you will use one of these words, right? If it's a word problem, you're typically talking what is your independent value? What is your dependent value? Like for example, if you have a job, right? If you have a job, the amount of money you make per hour is a big deal, right? Believe it or not, that is a function, right? Your hours, is that your independent value or your dependent value? Your hours. The number of hours you work, is that your independent or your dependent?
Independent.
It's your independent job. Because if you only work 5 hours, it's going to affect how much money you make, right? So therefore, the amount of money you make is your dependent value, okay? So that's when I would use that. I wouldn't say my domain at work is my number of hours. And my range is how much money I take home. So it just depends on your scenario. So opposite of domain is range. Opposite of input is output. Opposite of x value is
Y.
and opposite of independent is
Dependent.
That's a forward. That didn't get in that. Go with it. All right. Still just review, right? Yes. Here we go. So let's talk about identifying domain and range. So you have what's called multiple representations of a relation and a function. You can represent a relation and function via ordered pairs, here, via mapping, a table, a graph, right? Or a word problem. Those are our multiple representation. Ordered pair, table, mapping, graph, verbally. Word problem is what that is. Alright, so we're going to look at here, I have an ordered pair. When I'm listing them out, I want to list from least to greatest. So I'm listing from least to greatest. So I identify what's the domain values and I list them from least to greatest. Because I am writing them as a group or a set of data, when I list them out, I use braces. My braces are not the cutest. Maybe yours are better. That's actually a pretty good one for me. So we're going to roll with it. I'm going to identify my domain. So my domain values are 2, 3, 6, and -1. So when I'm listing them out, I'm going to start with what? -1. Then, perfect. Then, see, told y'all, it's going to be questionable. So just looking at my domain, is this a function?
No. Well, yes.
It is, right? Because if I look at my domain values, are any of them repeating? No, so I know it's a function. So the range of this function, my range is based off of my y values. So from least to greatest, what are my y values? 3,
4.
and you only, even if it's repeated, you only write it once. Are we comfortable?
No.
Still review?
Yep.
All right, perfect. Next we're going to talk about how to read a mapping. A mapping can be read from left. Mapping is read from left to right. So when I read a mapping, I read it from left to right. Starting here, I have 2, and 2 connects to 12. So my ordered pair is 2, comma, 12. And then we have 2,
-3.
and then we go from 1 to,
5.
and then we have 0 to 0, right? And
-1 and -3.
-1, -3. So those are my 5 coordinates. So I went from a mapping to coordinates. Ordered pairs.
I thought -1 was a 5.
Did it? What did I point it to? I wrote
Oh, it did.
It did. I don't know what I wrote. Let's try that again. -1, 5. And then, where was that at? Yeah. Okay. Were we good?
Yeah.
Perfect. All right, so our domain. So when I look at my domain, what I love about mapping is that it's already there. And I just got to write it out. So my domain is based off of this because it's my x's. And my range is based off of this group because it's my y. And now I just got to list them out, least to greatest. So we have -1, 0,
1 and 2.
1 and 2. And then my range is based off of my y. So I have -3, 0, 5, and 12. Is this a function?
Nope.
Yes.
Nope.
Why is it not?
The x values will be.
My x value repeated. Is it from my x group? Isn't there 2 lines coming from one value?
Mm-hmm.
Yeah. So right here I have 2, 2. So this is the problem. This guy right here is my problem.
That's what makes it not a function?
That's what makes it not a function. So this is a no. All right, so last one is looking at it from an equation. So if I look at this equation, it actually gives me my domain, right? So I am given my domain, and it wants to know what is the range given this set of domain values. So when I write this out, I'm going to automatically know what my domain is, because it's already given to me, -3, 2, 7. Show me it?
Yeah.
Just want to make sure I wasn't tripping. 11. And I'm going to do the work to figure out what my range is. So this is now an example of an input and a output situation, right? I'm going to input -3 into this, and I get 2 times -3 plus 3. And its output is going to be, what is my output, y'all? I have -6 plus 3. And what's -6 plus 3? -3. If you owe me $6, like, hey, I got $3 today. How much will you owe me tomorrow? you're gonna owe me 3 still. And owing somebody is not a positive thing. Okay, my next input is 2. So I'm gonna input 2. And so my output's gonna be 7. Alright, my next input is 7. I'm gonna do the work. And my output's gonna be
17.
perfect. And then my last input is 11. And my output's gonna be perfect. So for this given set, my domain is -3, 7, 17, and 25. Are we comfortable with inputs and outputs? Okay. Yes. -3, 7, 17, and 25. Okay, so is this relationship a function? It is. Perfect. Yes. How do we feel? Everyone still with me? Good. So we're going to jump to, we're going to save this page till tomorrow. So don't worry about this one, but what you're going to do is your exit ticket. And on your exit ticket, you're going to do problems A and B. So your exit ticket, you're going to do problems A and B. So everyone should have picked up the exit ticket in the green little basket. And you're going to do A and B quietly by yourself. Once you've completed A and B, you can go ahead and put your calculator and your supplies up.